Hi students, I'm Kailash. So in this online session, we'll be discussing about how to draw voltage versus current graph, shortly called as VI graph. So I'll be teaching you how to draw voltage versus current graph, one for a device which is going to obey Ohm's law, and the other one for a device which is not going to obey Ohm's law. Okay, we'll start. Now, let us stick to a circuit which is required to study VI graph for a given device. It may be a device which is going to obey Ohm's law, or it may not obey Ohm's law. So for both the devices, I'll be using the same circuit. And dear students, note that the circuit diagram is not there in the book. So just for reference, I'm going to draw the circuit here. Okay. So this is the circuit to study VI graph of a given device. Say for example, this device is made up of a conductor. All conductors will obey Ohm's law. Or this device, what I have connected in the circuit, may not obey Ohm's law. So all semiconductors do not obey Ohm's law. So the device, what I have connected in the circuit, may be a device which will obey Ohm's law or which may not obey Ohm's law. And if you look at the circuit, it consists of a battery, a variable source. I can vary the applied voltage to the device. And number two, a switch or a key. Now, how much voltage we are applying to the device, that can be measured with a voltmeter, and how much current is going to flow through the device, that can be measured with a ammeter. So the voltmeter is going to measure the voltage applied to the device, which may be a device obeying Ohm's law or may not be obeying Ohm's law, right? So the voltmeter is going to measure how much voltage is applied to the device. So it's going to measure the voltage V, and the ammeter is going to measure how much current is going to flow through the circuit, and hence the device connected in the circuit. So it is going to measure the current I. Okay, so what I'm going to do is I'll be using the variable source. I'll be varying the voltage applied to the device. So for each and every voltage, we'll be measuring the current recorded by the ammeter. So the voltage applied to the device is varied in a suitable steps, and for each and every applied voltage, we are going to record the current flowing through the device as indicated by the ammeter. And after tabulating the voltage values and their respective current values, we have to take voltages along x-axis and currents along y-axis. So generally, whenever we draw a graph, we have to take the independent parameter along x-axis and the dependent parameter along y-axis. So voltage, among voltage and current depends upon voltage. That is, for a current flow through a circuit, voltage is necessary. Whenever I say current is flowing through a circuit, that means we would have applied a potential difference or voltage. So which means current depends on voltage. So hence current becomes dependent factor, and hence I'll be taking it along y-axis, and voltage becomes independent factor. Therefore, all the voltage values what we apply to the circuit will be taken along x-axis. And after plotting the points, we have to join the points so that we get a trace. So depending upon the trace, we can infer whether the material is going to obey Ohm's law or not. Okay. Now, first of all, by Ohm's law, current flowing through a circuit is directly proportional to potential difference between the two, potential difference applied to the circuit. Or current flowing through a conductor I is directly proportional to potential difference between the two ends of the conductor. Now, when I remove the proportional sign and introduce equal sign, I get voltage V is equal to I into R. Okay, so voltage V is equal to I into R. To remember this formula, you can have the shortcut. V stands for vegetarian, and I and R, இதை ரெண்டையும் சேர்த்து you வேகமா படிங்க. ஐயர் அப்படின்னு வருதா? அப்ப vegetarian is equal to higher. So you know all higher are vegetarians. So to remember Ohm's law formula, the shortcut is vegetarian is equal to higher. So where V is voltage, I is current, and R is resistance. So on converting the proportional sign to equal sign, I introduce a constant of proportionality, which is none other than R here. So the R, the constant R is called resistance, and it is supposed to be a constant. Okay. Now let me take I to the left hand side in this expression. So I end up with V by I is equal to R. And you know R is a constant. So the ratio of voltage to current is always a constant. So the ratio of applied voltage in the circuit to the current flowing through the circuit should always give me a constant value. Only then R can be constant. Resistance of the material of the device what we have used in the circuit will be a constant. Okay, right. So whenever I say a device is obeying or a material is obeying Ohm's law, it means the resistance of the material should be a constant. We have to prove that resistance of the material or the device is a constant. To prove the device, to prove the resistance of the device is a constant, we have to prove V by I ratio to be constant. Okay, right. Now, once when I say Ohm's law is not obeyed, when I say Ohm's law is not obeyed, then the resistance of the device will not be a constant. Or in other words, the ratio of V to I will not be a constant. So whenever I want to prove the device is obeying Ohm's law, just prove the ratio of V to I. That is the resistance of the device to be a constant. And whenever I want to prove that device is not obeying Ohm's law, just prove the resistance of the device connected in the circuit is not a constant. That is to say, I have to prove the ratio of V to I varies is not a constant. Of course, when I change the voltage, the current will change. But the variation of current with respect to the voltage will be abrupt as far as devices which do not obey Ohm's law are concerned. Okay, right. Now, first let us draw VI graph for conductors. So generally, all conductors will obey Ohm's law. That is, the ratio of voltage applied to the conductor to the currents flowing through the conductor will always be a constant. That is, the resistance of the conductor will always remain constant. Okay, so as I told you, for various voltages applied to the conductor in a circuit, let us measure the current I, which is recorded by the ammeter. After tabulating voltage and currents, plot the points or the coordinates, okay, in the graph and join them. As far as a conductor is concerned, your graph will be linear. You will get a straight line. So whenever the graph between two parameters is a straight line or is a linear trace, then it means the two quantities vary directly with respect to one another. Or the quantity what I have taken along x-axis the quantity what I've taken along y-axis, in fact, will vary directly with respect to the quantity what I have taken along x-axis. So this will be true only when your graph is linear. Okay, right. So I will vary proportionately with respect to V. Fine. Now, I have to prove this material, the conductor, what I have connected in the circuit, obeys Ohm's law. So to prove it obeys Ohm's law, I have to prove the resistance is a constant. To prove resistance is a constant, I have to prove V by I is a constant, because you know V by I is V by I ratio is resistance. So how to do that? So first, let us find slope of the curve. So that trace what I have got here, the straight line. Okay, so let me find the slope of the straight line. To find the slope of the straight line, let me first cut or draw a right angle triangle. ABC, right angled at the vertex C. And if we look at the diagram now, the triangle, the right angle triangle, what I have drawn, cuts the trace, the straight line, what I have got, okay, the graph at 2 points. One is A and the other one is B. So this is the first thing what you should do whenever you are finding slope of a trace or of a graph. Okay. Now, next what I'm going to do is from the 2 points A and B, I'm going to draw two perpendicular lines, one each from B and A to y-axis. Okay. So let me draw a line perpendicular to y-axis from the point B so that it cuts at a current reading, say B1 on the y-axis. And likewise, let me draw a line perpendicular to y-axis from the point A so that it cuts the current axis, that is y-axis, at the reading A1. For the sake of convenience, let me consider like this. So A1 happens to be, say, 10 and B1 is 7. For example, just for the sake of convenience, I'm choosing these arbitrary values. Is it clear? Right. Now again, from the 2 points A and B, the triangle cuts the trace at 2 points A and B. So from those 2 points, you are supposed to draw parallel lines, perpendicular lines to both y-axis as well as x-axis. So I have drawn perpendicular lines to y-axis. Now from these 2 points, I have to draw two lines perpendicular to x-axis. So from B, let me draw a perpendicular line to x-axis. So it cuts the x-axis at a reading B2. And since we have taken voltage along x-axis, the reading B2 corresponds to voltage value. Okay, right. So likewise, from A, let me draw a perpendicular line to x-axis again. It cuts the voltage axis at the reading A2. For the sake of convenience, let me consider B2 to be, for example, 10 volt, and A2 to be 15 volt, and A1 to be 10 ampere, and B1 to be 7 ampere. So when the applied voltage is 10 volt, then the current through the circuit will be 7 ampere. So when the applied voltage is B2, then the corresponding current through the circuit will be B1. When the applied voltage is A2, then the corresponding current flowing through the circuit will be A1. So that is how we find a corresponding current for a given voltage. Okay, so the two values what we have assumed are A1 to be 10 ampere and B1 to be 7 ampere. I hope I'm correct. And B2 to be 10 volt and A2 to be 15 volt. I hope I'm correct again. Now, next what I'm going to do is I'm going to find the difference between the two readings A1 and B1. So which will give me change in y coordinate. Because slope is given by the formula y2 minus y1 divided by x2 minus x1, or delta y divided by delta x, where delta y is change in y coordinate and delta x refers to change in x coordinate. So let me find the difference between A1 and B1, the readings, the readings A1 and B1. Okay, right. So the difference between these two will give me change in y coordinate. Now, since we have taken current along y direction, the change in y coordinate will give me change in current. So 10 and 7 are y coordinates what we have considered. So 10 minus 7 will give me 3. So change in y coordinate is 3. And since we have taken current along y-axis, this change in y coordinate delta y will give me the change in current, that is nothing but 3 ampere. Okay, so in our example, del I is 3 ampere. Likewise, let me find the difference between A2 and B2. And since we have taken voltages along x-axis, the difference between A2 and B2 will give me change in x coordinate. That is nothing but del x. Okay. So which is nothing but which will be equal to del V. Since we have taken voltages along x-axis, the difference in the x coordinates A2 and B2 will give me change in voltage. That is nothing but del V. So which happens to be 5 volt here. So change in x coordinate, that is del I is equal to 3 ampere, and change in x coordinate, that is del x is equal to 5 volt. So just remember the two values. Del I is 3 ampere and del V is 5 ampere, or 5 volt in fact. Okay, and del I is equal to change in y coordinate del y, and del V equals to change in x coordinate del x. Now let us find slope. You know, slope is given by m is equal to change in y coordinate del y to the change in x coordinate del x. Okay, that is slope m is equal to, now change in y coordinate is del I. So del I. So instead of del y, we put del I here. And change in x coordinate is del v. So we put del v here. Okay. Now let me substitute the values of del I and del v. That we shall do last. Okay. Now let me rub off all the writings, whatever I have done. You just remember the values. Del I happens to be 3 ampere and del V happens to be 5 volt. Just remember those values. Okay. Let me put it over here. So del I was 3 ampere and del V was 5 volt. Okay. Just remember these two values. Now, if we look at the formula for slope, what we have got, it is current divided by voltage. So in the numerator, we have change in current. Change in current is nothing but current. And in the denominator, we have change in voltage. Change in voltage is nothing but voltage. You know, voltage by current, that is V by I, will give me resistance as per Ohm's law. But when I take slope of VI graph, I have got current divided by voltage. So voltage by current gives me resistance. So what will be current divided by voltage then? It will be inverse of resistance or reciprocal of resistance. So M is equal to 1 by R. So whenever I find slope of VI graph, I will always end up with not resistance, rather reciprocal of resistance. So what should I do to get resistance then? So after finding the slope, to get resistance, I have to take reciprocal of the slope. So M is equal to 1 by R. Therefore, I get reciprocal of the slope, that is 1 by M is equal to R. So as far as a VI graph is concerned, the slope of VI graph will always give us inverse of resistance or reciprocal of resistance of the device what we have connected in the circuit. So to get resistance of the material, I have to take reciprocal of the slope. So it's an important objective question. So what is the slope of VI graph is going to give us? So this is the question what they're going to ask, and they'll give you 4 options. So our answer should be reciprocal of resistance. Now the reciprocal of resistance is called conductance. We'll be seeing it in the later part of the lesson, current electricity. Let me just introduce this word to you, become familiar with this, okay? So the reciprocal of resistance is called conductance. Therefore, slope of VI graph gives me, I can give you 2 answers, right? Number 1, reciprocal of resistance. And you know, reciprocal of resistance is called conductance. So slope of VI graph will give me reciprocal of resistance, or simply I can say conductance. And the reciprocal of slope will give me the resistance of the device connected in the circuit. Okay, right. So after finding the slope, I have taken the reciprocal of the slope. So I ended up with the resistance of the device. Now, I have cut a triangle ABC in this particular region of the graph, and I have found the slope, isn't it? Now, whenever my graph is a straight line, the triangle ABC can be cut or drawn anywhere in the, anywhere or at any part of the curve. I can draw. So the graph is linear. So whenever you get a linear graph, wherever you draw the triangle like this, however large the triangle may be or however small the triangle may be, that doesn't matter. I can draw this right angle triangle anywhere on any part of the curve, and I can find slope as I did here. So the slope, wherever you draw the triangle, and if you find the slope, if the trace is a straight line, if the VI graph is a straight line, then the slope will always be a constant. If the slope always is a constant, then the reciprocal of the slope, which is nothing but resistance, will also be constant. Is it clear? So I can draw triangle over here, and I can find slope as I did here. And I can also draw the triangle over here. And again, like we found the slope earlier, I can find slope with respect to these two triangles what I have drawn. So the slope of the curve, the trace what I have got, will be same if we find the slope with respect to the triangle. What do you find at the topmost place or at the bottommost triangle? If I find the slope with respect to the bottommost triangle, or if I find the slope with respect to the triangle ABC, what I used as a demo. Okay, so all these three slopes will be same. So whenever the graph between two parameters is a straight line, then the slope will always be a constant. Hence, reciprocal of the slope, in this case it's resistance, will also be a constant. Whenever resistance of a device is constant, it means V by I. V by I is resistance, right? So since R is a constant, V by I is a constant. Since V by I is a constant, V is equal to I into constant. If I remove the constant, then equal sign will change to proportional sign. So I should write I is proportional to V rather than V is proportional to I, because I is dependent on V. So I is proportional to V, which means Ohm's law is obeyed. Is it clear? Right. So hence Ohm's law is obeyed. So the devices which obey Ohm's law are called ohmic device. How do you say Ohm's law is obeyed? Whenever I want Ohm's law to be obeyed, the device what I have connected in the circuit should give me a constant value of resistance for all voltages and currents. That is V by I ratio should be constant. So by drawing the graph, we have found the slope. We can find the slope at various parts of the curve, and we can prove the slope to be constant, and hence the reciprocal of the slope to be constant. Reciprocal of slope as far as VI graph is concerned gives me resistance. So since the resistance is constant, we say Ohm's law is obeyed. If a device obeys Ohm's law, then I'm going to call it as ohmic device. So all metallic wires or all devices which are made with metals or conductors are generally called ohmic devices. Okay, now what will I get when I draw the same VI graph for a semiconductor? You know, semiconductors are those which partially allow the current to flow through. Okay, so as far as a semiconductor is concerned, the graph between voltage and current will never be a straight line, will be non-linear. Whenever the graph between two quantities what we have taken in y-axis and x-axis, or x-axis and y-axis, gives me a non-linear trace, then the two quantities do not vary proportionately with respect to one another. If I say I varies proportionately with respect to V, it means if I increase the voltage by 2 times, the current should also increase by 2 times. If I increase the voltage by 5 times, the current should also increase by the same 5 times. That's what we mean by proportionate change. But whenever I is not proportional to V, on increasing the voltage, the current will increase. Of course, I accept, but not proportionately, which means if I double the voltage, the current has to be doubled, but will not be doubled, because there is no proportionate change between I and V, because they are not proportional to each other. So when I double the voltage, the current may increase by 3 times, or even 5 times, or even 7 times. So on changing the voltage, the variation of I will not be proportionate, but will be abrupt. Okay, so for semiconductors, if I attempt to draw a graph between voltage and current, I will be getting a non-linear trace. Since the graph is non-linear, only when the graph is linear, I'll be getting the slope as a constant value, and slope calculated in different parts will be constant. But whenever the trace is a non-linear trace, then if I find slope at various parts of the graph. Say if I find slope with using this triangle, and again using the triangle, what you see at the bottom, the two slopes what I get will be different. Only it will be same only when the trace is a straight line. So since the trace is non-linear, the slope will be different. And therefore, reciprocal of slope will also be different. You know, slope of VI graph will give me reciprocal of resistance. Reciprocal of slope will give me resistance. So since the reciprocal of slope is not a constant, the resistance of the device connected in the circuit will not be constant, which means V by I ratio is not a constant. When V by I ratio is not a constant, it means the device does not show a constant value for its resistance and hence is not going to obey Ohm's law. Is it clear? Therefore, graph being non-linear, slope will not be a constant, implying the reciprocal of the slope, which we call it as resistance, is also not a constant. Since the resistance doesn't work out to a constant value, Ohm's law is not obeyed. Hence, those devices which do not obey Ohm's law are called non-ohmic devices. Examples for non-ohmic devices are devices which are fabricated with semiconductors. Example, I can quote diodes, transistors, etc. So all these are all fabricated. The devices, whatever I told you, diode. A diode generally is used to convert alternating current to direct current. A transistor, a component, okay, which is used for amplifying weak signals. So these devices are made up of semiconductors. So they don't obey Ohm's law. So those devices which do not obey Ohm's law are called non-ohmic devices, or in other words, non-linear conductor of electricity. So non-linear conductor of electricity means their VI graph will not be linear. Okay. So thanks a lot. See you in the next session. Bye.